That's great. Now, as far as I remember, I need to basically write the differences between progressive and stationary waves so you guys can actually do them along with me. So that's for the first one. All points have the same amplitude for the progressive wave because they all get the chance to, go at the top or below. Then crests and troughs move along the wave, like you can see. Then phase varies continuously and neighboring particles are always out of the phase with each other. Then frequency depends on V is equal to F lambda, and progressive waves can be formed at any frequency. That's very important. Okay? Now, in this one, stationary waves, amplitude vary. So at antinode, it's maximum, and at node, it is 0. Now, nodes and antinodes stay at their position. They basically never shift, they just stay where they are. And then this is the most important thing that I want to tell you. Let me write full. Between the adjacent nodes, all points vibrate in 0-degree phase difference. So in stationary wave, there are only two phase differences: 0-degree or 180-degree. There is no other one. Just to tell you. Which means that basically between like one node to another, where the yellow is, they will all have 0 degrees with each other. But the next one where the green line is, those points will have 180 phase difference with the marked highlighted one. Okay. And then only at very specific frequencies, stationary waves can be formed. Is it clear? Okay, you can write this down and then we'll see. Hello Aman, how are you?
Hi, sir.
Okay. Okay, so now when I say stationary waves are formed in a very particular frequencies, at very particular frequencies, we can actually see how and why. So basically, there are three different systems through which you can create stationary waves. The first system is called the closed system. Now, in a closed system, basically it means that there are like two ends which are completely closed like this. So between that, you can have a string or something, and we can say that this length of the string is L. Let's call this L. Okay. So if you just move it once, what's going to happen is that this string, which was initially here, if you just pluck it once, it will go up and then it will go down. Do you guys understand this? That's just doing it like once. This is basically the fundamental wave that you can create. So, because this is L, and if you look at it, this is from a node and there's another node, and I told you from a node to node it is actually half lambda. So what we can say is, we can say, right, it means that the length of the string right now is at half lambda. So it's creating a wave that is of half lambda, which means the lambda here will be 2L by 1. Is it clear? Alternatively, because we know that frequency and wavelength are connected by this equation, so which means that for frequency we can write it like this. Frequency, we can replace lambda with frequency, frequency or velocity. So it will be velocity times 1 over 2L. Okay, is it clear? If you have any questions, let me know, okay? Now, the next time the stationary wave is going to be formed, when you increase the number of strokes on it, it's gonna look like, if you make it like 2 times, pluck it twice, at a certain frequency it will be like this. So now it is twice, right? Now, because this is a node and this is also a node and this is also a node, so basically the whole distance is now 1 lambda. So that means that if I want to find the wavelength, it will be lambda equals to length, and I could write it as lambda is equal to 2L by 2. Can I do that? It won't change any fact, right? And then for frequency I can write it as velocity times 2 divided by 2L. You can switch it using the equation V is equal to F lambda. Okay. Now, if I plug it 3 times, so basically
And
with
what's the point of all this?
sorry?
What's the point of all this?
Basically it will tell you that if you want a stationary wave that looks like the first one or second one, what would be the frequency of it? At what frequency it can be formed? Because stationary waves cannot form at every frequency, they're specific. Okay.
Okay, for example, in the second one, the thing you drew, why would you write 2L over 2 if it's gonna end up being L anyways?
I'll tell you in a bit, okay? Just write it like this. There's a reason I do that.
Okay.
In the third one, which means it's called harmonic. So in the third harmonic, which means if I pluck it thrice, it's gonna make a wave like this. You get my point? Now you see there are 3 humps, which means now it is plucked thrice. So this is node, this is also node, this is also node, and this is also node. So if you find the wavelength of this, it is going to be half plus half plus half. So it's going to be 1.5 lambda. Or you could say 3 by 2 lambda, right? Like that. So now I can say in this one, in the third one, lambda is equal to basically 3 by 2 lambda is equal to the length of the string right now, which translates into 2L by 3, and for frequency it will be equal to V times 3 over 2L. Do you guys understand this? How I am doing this? Now just look at the pattern, what is happening. Every time from the fundamental as I go forward, I see, oopsie, let it load. I see a general formula appearing here, and the general formula is that for lambda it is going to be 2L by n, and for frequency it is going to be V times n over 2L. So if I say I want you to find the frequency of 1000th harmonic, what will you do? For n you just put 1000 in it. Do you understand? So for two closed systems we get where n is equal to 1, 2, 3 and so on. Is it clear? Any questions here? You know what this is? What kind of wave formed? What instrument forms this kind of wave? It forms anything like a guitar, right? So if you notice that a guitar has basically one closed end and another closed end, so the strings are closed between these two. You know, right? That's just like that. Is it clear? Any questions now? So that's how it works. So from these general formulas, if you know the length, you can actually find anything, and then of course you can find the frequency or the wavelength of any guitar string or anything like that that you move. All right, you guys have written Aman, Aisha, Hamad.
Yes.
Javeria is here or no? Okay, great. Now the other system is like a flute, right? Where it is one end open and one end closed. There are certain instruments which also create stationary waves. So like this. In one end open and one end closed, what happens is that, let me just don't draw it yet. I wanna basically copy this first. So in a one end and one closed system, we can say basically the length of the pipe or something like this is L. You can say that. So when we're looking at the fundamental wave, it would be formed like this. So there will be a node at this end, antinode at this end. This is basically the fundamental one. So now we know that the wavelength here would be from node to an antinode, it is a quarter lambda. So length will be equal to a quarter of lambda. And now we can write lambda as 4L by 1. Okay. And the frequency here would be equal to V times 1 over 4L. Is it clear? Then the next frequency will be formed when it would look like this. Now there is a node, there is an antinode, there is a node, there is an antinode. So in this one, it is basically about, you see, node to node is half lambda and node to antinode is quarter lambda. So this is 3 by 4 lambda. So the next frequency will be 3 by 4 lambda is equal to length. So lambda will be 4L by 3, where frequency will be 4 times 3 divided by 4L, like that. And now the next basically forms like this. Oh my god. So it goes like this, and this, and this. And like this. Okay. So there is a node, antinode, node, antinode, node, and antinode, like that. Now if you look at it, this is like half lambda, this is also half lambda, and this is basically a quarter lambda, like that. So which means that if you add them together, this is going to be 5 over 4 lambda, which is equal to length. So length will be 4L by 5. And I hope you guys see the pattern here. And the frequency will be V times 5 over 4L. So now for one end open and one end closed, our general formula can be stated as lambda equals to 4L by n and frequency equals to V times n over 4L, where in this one n is basically the number of harmonics are odd numbers like 1, 3, 5, 7 and so on. You guys get my point? Okay. Okay. Now the next thing is that if both ends, like a bagpipe, both ends are open, then what happens? So just don't draw it yet, just need to So what I'm saying is, suppose that this is the length L of the pipe that is open from both ends. Now if you draw the fundamental wave, it would basically be like this. So this is node, antinode, antinode, like that. Now this is the fundamental one. And now what you can do is you can see that because antinode to antinode is half lambda, so this is going to be half lambda equals to L. So lambda is 2L by 1 and the frequency will be V times 1 over 2L, like that. In the next one it is going to be like this. Uh-oh, this is a difficult one for me. So in 10 minutes when the meeting ends, you guys need to rejoin. Like this, okay? Now here we have an antinode, node, antinode, node and antinode, like that. And of course between two antinodes, so it is basically, even if you don't write it, that's fine. This is half lambda from here till here, and this is also half lambda from here till here. So basically this makes it like lambda equals to L. So we can write it as lambda is equal to 2L by 2, just to make the pattern. And then frequency can be written as V times 2 divided by 2L. For this one, we could say that there will be basically, oh my god, I made more. like this, right? So ignore the drawing. So this is going to be antinode, 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 antinode. So half lambda between this and this, half lambda and half lambda from antinode. So now if you look at it, it's gonna be like lambda equals 2. 3 by 2 lambda is L, so lambda will be 2L by 3, and the frequency will be V times 3 over 2L. Now the pattern is very clear here that basically the general formula for this is going to be for lambda first. Lambda is 2L by N and frequency is V times N over 2L. And now where N is equal to 1, 2, 3, 4 and so on. So for the two end closed and two end open, the formula is the same, but for one end open and one end closed, the formula is a bit different, and of course the number of harmonics as well. Okay, is it clear? Do you guys get my point?
Yes, sir.
Okay, you can write it down, then I'll show you what type of questions you will encounter and how to solve them. Okay. Should I go forward now? All right. Now let's check out a worksheet. Okay. Now, first of all, we're going to look at a question like this, right? This one. Now, in this question, it says that a musical instrument bugle is long tube with mouthpiece at one end. The other end is open. It means that this is one closed and one end open. The moment you see this, you should recall the formulas that I've told you. And now it says that the lowest frequency of sound that the bugle can produce is 92 Hertz. So what are the different frequencies can be produced? Right. Now, who can tell me what is the formula with respect to frequency of one end closed and one end open? Yes, please. Go on.
Sir, we just took it.
We just.
We just took it. I didn't memorize it.
Yeah, but you did write the notes, didn't you?
Yeah.
Look at the notes then. Yes, please. No idea. That's not fair. V times n over 4L. It means you guys are not writing the notes. Am I right about it? Ahmad, Aman, Aisha. What is this?
I do write them, but I write them while I'm watching recordings.
Okay, but that's not fair. You should, note them down every single time. Now, we also know that n is equal to 1, 3, 5. It's odd numbers, right? So they have given you 92 as the first one. So it is 92. We don't know v. It is 1, 4L, which means 92 is equal to v upon 4L. Like that. So in that case, then the next one will be equal to f equals to v times n is n upon 4L. So this is 92, right? So 92 times the next one is 3. So 92 times 3 is 276. Then the next one will be 92 times 5, which is 460. So this is the answer. If you don't remember the formula, you won't be able to solve these questions. Do you understand?
Yes.
Yeah. Okay. Now, I want you guys to find me this one. First and second higher note, okay? Find me this and then you can go. When the meeting ends, please rejoin. Okay. Okay.
Sarah said
B.
D.
D. Okay, let me see. So F is equal to V times N over 4L. The first frequency was 75 V upon 4L times 1 because N is 1, 3, 5 and so on. So yeah. So the next frequency will be 75 times 3. That's 225 and yes, that's correct. Is it clear everyone? Is it clear? Any questions? Alright. So I guess I'm gonna see you guys in the next class then. Have a nice day.